Hello everyone, welcome to my channel. In previous lectures, we have seen different types of activation function, their pros and cons. Now let us move to an important neural network architecture called multi-layer perceptron, commonly known as MLP. A multi-layer perceptron is a feed-forward neural network, which means information flows only in one direction from input to output. An MLP is made up of several key components: an input layer, one or more hidden layers, an output layer, and activation functions. The input layer receives the raw features, the hidden layer performs computation and learn representation, and the output layer produces the final prediction. Because it contains one or more hidden layers, the MLP is considered the simplest form of a deep neural network. MLPs are powerful because they can model nonlinear relationships which a singular perceptron cannot. Now, now let us understand the structure of a multi-layer perceptron. First, the input layer. The input layer simply receives features from the data. For example, if we have an image patch with 64 pixels, then we will have 64 input neurons. Next come the hidden layers. These are the core of MLP where learning happens. Each neuron in a hidden layer performs two steps. First, it computes a weighted sum z equal to w transpose time x plus b. Then it applies an activation function a equals to f of z. Here w represents weights, b is the bias, f is an activation function like ReLU, tanh or sigmoid. Finally, we have the output layer. The activation function in the output layer depends on the task. Sigmoid for binary classification, softmax for multi-class classification, linear activation for regression problems. So the structure of MLP is flexible and adapts based on the problem we are solving. Now let us see how learning happens in a multi-layer perceptron using the forward pass and backward pass. First, the forward pass. During the forward pass, information flows from the left to right, starting from the input layer towards the output layer. For a given layer L, the computation is ZL equals to WL times 8L minus 1 plus BL AL equals to f of ZL. This process continues layer by layer until we obtain the final output. Next, we compute the loss, which measures how far the predicted output is from the two target. After that comes the backward pass, also known as the backpropagation. During the backpropagation pass, gradient flows from right to left, and the weights are updated using the gradient descent w equals to w minus eta times del L over del W. Here eta is the learning rate. The learning process follows these steps: forward pass, compute loss; backward pass using the chain rule, update the weights, repeat until convergence. This combination of forward propagation and backward propagation allows the MLP to learn complex patterns from data. To summarize, a multi-layer perceptron is a feed-forward neural network that uses hidden layers, activation function, and backpropagation to learn powerful nonlinear representations.